Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Exponential Function Basics. Concept number 3, the range of an exponential function. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a new paradigm. I want to include everyone who needs a boost in Algebra 2. And if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I definitely would. So inbox me at memedicine@gmail.com to get your healthy dose by ordering and purchasing the complete Algebra 2 Cram session beyond the exponential function basics. You have lots of friends, peers, classmates, and or colleagues who are also taking Algebra 2 with you, and they could definitely use a boost as well. So tell them to inbox me at memedicine@gmail.com to purchase the complete Cram session. You'll be glad you spread the word because they'll make great study buddies. And last but not least, the concept of cramming often has a negative connotation, but what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive to your overall learning process. We're not hurrying here, we're cramming, and there is a difference. Hurrying is jam-packing tons and tons of unorganized information into your mental DNA over tiny amounts of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to have been an instant. All right? So let's delve into concept number 3, the range of an exponential function. Exponential functions. What is the range of the exponential function y equals b to the x? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you were able to press pause and think of a solution for the range of an exponential function. All right, but if you didn't, that's completely fine. Let's tackle this together. In the general format for the exponential function, y equals b to the x, we have b, or our base, that's a constant, x, that's the independent variable, or our input, and this is what we call the exponent. And then we have the output, or the dependent variable y, and that's called a power. Oftentimes people call the exponent a power, but that's actually a misnomer. Let's say we were to insert a 2 for x, then the result, or dependent variable, or output, y, would be the second power of the base b, okay? So that's how you express that concept. Now let's take a look at what this would look like if we were to plot it. So this is our classic Cartesian coordinate xy plane. And here we have our y-intercept at 1, because you have to remember, for any for the input of 0, any constant b, the output is going to be the result 1. Okay, so anything raised to the 0 power yields 1. And then this is what our function is going to look like when the constant b is greater than 1. Okay. But let's just think about a few things. Let's say, well, first of all, this is a classic exponential growth function, because as you can see, the function is growing away from a vertical asymptote of y equals 0 as x increases, okay? So the dependent variable y is increasing as x is increasing, all right? But what you also have to note is that there are a few caveats for the base b. when we're dealing with the exponential function y equals b to the x power, first of all, we don't want b to be negative. Okay, b can be negative, but for our purposes, that's not what we want. So no negative b's, all right? Okay, so but let's say, for instance, we were to plug in a negative value for the constant b, -2, for example. What would occur if we plugged in the value 0.5 for x, or 1/2? Well, we know that in order to evaluate this, we raise the base to the numerator and take the nth root of the denominator. So what we would end up with is -2 to the first power. We would have to take the second root, or the square root of that. And there are two problematic concepts that result here, okay? First of all, we would have to evaluate the square root of -1 if we were to break this up, and the square root of -2. Well, the square root of -1 is the imaginary number I. We don't want any imaginary numbers here, okay? And the square root of 2 is an irrational number. All right, that means when you try to evaluate it, the decimal repeats on and on forever. And so this value would be 1.41, I think, 356 or something like that. And it would just go on and on forever. The decimal would never repeat or terminate. It would just continue. So the range, okay, that's the y outputs that result from the domain. The range is always going to depend on whether or not the sign in front of b is positive or negative. So remember that here we're only concerned with positive b as shown, okay? Alrighty then. Yeah, that's pretty much what I wanted to say about that. Oh yeah, and also we don't want b to ever be equivalent to 1, okay? This is not good, no bueno. Because let's say that you were to try to evaluate the constant b, whether it's from -infinity to infinity, you're always going to get the answer 1. And if b equals 1, then our function y equals b to the x is not a legitimate one-to-one function. Rather, it's a one-to-many relation. That means if b were 1 and you were to draw a horizontal line, the horizontal line would touch the curve at every place or several places. And this means that the relation y equals b to the x would return the same output value, the same y value of 1, okay, for all input or independent variables of x, okay? So yeah, that's pretty much what I want you to know. No negative b's, and we don't want b to be -1. Oh yeah, and also here we're showing the case where b is greater than 1, but let's say that b is not negative and not equal to 1 either, but instead let's say that it falls between 0 and 1, not being equivalent to 1 and not being less than 0, we're going to get our classic exponential decay function, okay? And where y, or the output, is decreasing as x increases, decreasing in a way that it's always approaching the horizontal asymptote y equals 0, but it never touches as x increases, okay? So we know that the range is the output that results from the domain. And if you watch the previous Cram session video, that if you purchase the entire Cram session, you would know that the domain is the set of all x values that makes the function true. And the domain of the exponential function y equals b to the x is going to be the set of all real numbers, okay? And so for this set of all real numbers, in this instance, for y equals b to the x, the range is going to be anything bigger than the horizontal asymptote y equals equivalent to 0. So the range is y is greater than 0. Sometimes people say that the range of y equals b to the x is all positive numbers. And remember that 0 is not a positive number. You can think of it as neutral. It's neither positive or negative. Okay? So this is our answer. The range is y is greater than 0 or all positive numbers. Okay? All right, so thanks for tuning in. And as you were able to see, intellectual comprehension of this material was not difficult at all. And in the short amount of time it takes to complete the entire Cram session after you purchase by reaching out to me at memedicine@gmail.com, you'll be able to answer a battery of questions about any Algebra 2 concept. So good luck studying, and thanks for tuning in.